Hey everyone, and welcome. Today, we are diving into a topic that, honestly, might be the single most important skill in all of machine learning. We're talking about feature engineering. It's the secret sauce. It's how you turn messy, raw data into pure gold for your models.
This quote just nails it, right? This is the core idea for our entire chat today. It's not always about chasing the fanciest, most complicated algorithm. Nope. It's about feeding any algorithm the absolute best ingredients you can. It really is that simple. Better features mean better results. Period.
So, let's start at the beginning. What in the world is feature engineering, really?
Okay, think of it like this. You're a chef, and you're about to cook a gourmet meal. You wouldn't just throw whole, unwashed vegetables into a pot and expect magic to happen, right? Of course not. You've got to wash, peel, and chop them. Feature engineering is the exact same idea, but for your data. You're prepping it, making it easy for your algorithm, your chef, to understand and create something amazing.
And this right here is a perfect example of how simple yet powerful this can be. Imagine you're trying to predict house prices. A model might really struggle to figure out how length and width work together. But if you do a tiny bit of work up front and create one new feature, area, well, you've just handed the model a massive clue. You've made its job so much easier. That's the whole game.
So we know we have to prep our data, but data comes in all different shapes and sizes. So how do we actually handle all these different types?
Let's start with numbers. Let's say you have a feature for age that goes from 0 to 100, and another for income that goes from 0 to, 500,000. That massive scale on the income feature is going to totally dominate the age feature. It's just going to drown it out. So we use techniques like normalization to squish everything into a range like 0 to 1, or standardization, which makes the average 0. The point is, they put all your numbers on a level playing field, which is absolutely critical for a lot of algorithms.
Now for categories. This is such a common question, and it's a classic trap. You've got colors like red, blue, and green. Can't we just say red is 1, blue is 2, and green is 3? Seems easy enough, but it creates a really subtle, hidden problem. You're accidentally telling your model that green is somehow more than blue and blue is more than red, which makes zero sense.
So the solution is this really clever technique called one-hot encoding. Instead of one column with a fake order, you basically blow it up into multiple new columns, one for each possible category. Then, an item gets a 1 in its category column and a 0 in all the others. Let me show you what I mean.
In Boom, here's what that looks like. See? A row that used to say red now has a 1 in the isRed column and zeros everywhere else. We've managed to represent that categorical info perfectly, but without creating some fake numerical relationship. It's clean, it's clear, and trust me, your model will thank you for it.
Okay, we've covered how to clean up the data we already have. Now for the really fun part, the creative part, making brand new features and then picking the best of the best. This is really where your own expertise and creativity come into play. Just like we made area from length and width, you can combine other features to uncover these hidden gems. For example, creating something like purchase frequency by dividing the number of purchases by how long they've been a customer, that one feature could end up being the most powerful predictor in your entire model.
But you can get carried away and end up with hundreds of new features. So how do you pick the winners? Well, there are 3 main ways. Filter methods are like a quick first pass to weed out the obvious chunk. Embedded methods are my favorite. They build the selection process right into the model training. And wrapper methods, well, they're the slowest, but they test all the combinations to find the absolute best set.
All right, let's get practical. What tools should you actually be using for this? And maybe more importantly, what are the huge project-killing mistakes that you absolutely have to avoid?
So Scikit-Learn is going to be your best friend. Seriously, it has everything you need for the stuff we just talked about. Scaling, encoding, selection. But the real hero here is something called pipelines, which lets you lock in all your steps. If you want to get fancy, feature tools can even help automate some of this for you.
And here is why pipelines are so non-negotiable. This quote says it all. If you transform your training data one way and then you forget or mess up a step when you get new data in the real world, your model is going to fail spectacularly. Pipelines prevent this. They are your safety net. They guarantee that every piece of data gets the exact same treatment every single time.
Now, speaking of disasters, there is one mistake. One that's so bad, so common, and so devastating that we have to talk about it. What is the one thing you must never, ever, ever do?
Data leakage.
This is when information from the future accidentally contaminates your training data. For example, using information from after an event to predict that same event. It's like giving your model the answers to the test. It'll look like a genius in development, getting a 100% score, but then it will completely fall on its face in the real world because it never actually learned anything.
And of course, there are other traps. Don't go crazy creating hundreds of super complex features when a few simple ones do the job. That's over-engineering. Don't just delete rows with missing data. Sometimes the fact that it's missing is a signal in itself. And maybe the most important one, talk to the domain experts. The person who knows the business will often know which features matter most.
So how do we pull all of this together? What does it actually mean to master the craft of feature engineering?
This slide right here, this is your checklist. A great feature isn't just about boosting a score. It's one that makes sense, one you can explain to your boss. It's a feature that doesn't break if the data changes just a little bit. And most of all, it's one that works reliably out there in the real world. That is the gold standard.
And that brings us to our final thought. At the end of the day, all data tells a story. A machine learning model's job is just to read that story. Feature engineering, that's how you teach your model the language. It's how you give it the tools to understand the plot, the characters, and the narrative hidden in all those rows and columns. Master this, and you'll unlock stories you never knew were there.